or a pound figure. But again, most research, most work in this area tends to focus upon proportionate or percentage return. And hence you can see there, taking the actual return and dividing by the original price. And usually, as I did in the title of today's talk, when people say returns, they actually mean this percentage or this proportionate notion. So again, in common parlance, you might say a 10% return or a 20% return. So it is that notion of our proportion or our percentage.
Do you think this model they can apply to any investment, doesn't matter investment in projects, investment in financial products, not only in stock, that model you are describing? Because when you invest in one project, also you expecting a return on investment. What is your price in the future? Is the same approach for doesn't matter what product is that? Project tangible, intangible, financial product, non-financial product. One financial analysis.
Okay. I think what I said as I was going along was in principle. All right? Now, in principle, what we have here are two different, and if you take the earnings per share idea, very similar notions that say how we can get an idea of what determines value. Okay? Now, that does not necessarily mean, which I'm going to say in a moment in a slightly different context, that does not necessarily mean that we can just automatically do these calculations and say this is the value. Now, if you're talking about, which again wasn't the central focus of today, but if you're talking about investment appraisal, so if you're talking about what sometimes people call capital budgeting, if you're thinking about undertaking a new investment and you want to know whether that's worthwhile, then it is a very similar approach that you take, or can take, to what I've looked at here. Okay? But in that circumstance as well, we are talking about future values. And as I've said already, future values are not known with certainty. Now, if it's a very big investment project, you might get someone, maybe not even get me, to do some sort of forecast to say what is likely. But I might be wrong. You just don't know for sure.
Yeah, I think some companies, they have a choice. They analyze, I will invest in this project or I will buy a stock.
Yeah, I mean, you could use it to do that evaluation as well, but the same thing will apply. That might say, invest in the stocks, and then in 3 years' time you find, okay, should have done the opposite. Yes? So I think, I always lose track of the slides, but I think that's kind of the next point that I was coming on to, or coming on to in a moment. Yeah, no, that was the next point. So, what we had there was the notion that, we're talking about future values. Hence, we do not know with certainty. There is uncertainty, or what is quite often labelled in this area, risk. And in terms of the figures there, whether we're talking about the cash flows or the dividends or the results of using those models, the best those figures are expected. So expected price or expected return. Inevitably, there will be some variation around that expected. And so, as I've said, on some occasions it might be lower. On some occasions it might be higher. Now, all we're getting, even from the principle of those two models we looked at, is an idea of our expected price or our expected return. So to try and go a little bit further forward, we need to recognise that there is risk. We need to recognise that there is variability. I didn't expect that to come up. Oh, there we go. And one of the most widely used measures of risk, of variability, is a notion referred to as standard deviation. So in terms of empirical work in this area, and indeed theoretical work, quite often people will make use of this notion of our standard deviation as a measure of risk, or if you like, as their preferred measure of risk. Doesn't mean it's the only measure. In some circumstances, you might want to use a different one. But it is the one that's quite often used within the finance literature. And you can see here, I think I use a little bit of this subsequently, that again, a little bit of shorthand is used to represent both of these ideas. So here is our expected return, and here is our standard deviation. And my example, as you can see, or sorry, someone else's example, Samuel's et al., okay, as you can see, has 5 stocks, 5 shares. In each case, the suggestion is we've got our expected return, but there's also some risk. And here we have some figures for risk.
Can we apply the same theory to projects when we invest in projects? The risk can be quantified.
As long as you can quantify.
Maybe study all the history of the project.
Okay, that is possible. I mean, that's again, but it's a different context where the talk's going today. So we're talking about the future, but how do we quantify all this? We take information from the past. Okay, and I'll come back to that a bit later on. But have a look at what we've got here in terms of those 5 possible shares or those 5 possible stocks. And just reflect upon which an investor should choose on the assumption they can choose only one, or indeed, if you want to think of it slightly differently, which one you would choose. And maybe a little picture, so I'll step back in a second, maybe a little picture to make that thought process a bit easier. So have a look at that a little bit while I try and address the question. In the sense of the example, Samuel's et al. Made it up, I guess. But in terms of how you do it for a particular stock or share that did exist, you'd be looking at past data again. Historical data, yeah. So, any suggestions as to which of those you choose? Sorry, someone brave enough to say? Okay, no consensus anyway. Right. So let's consider at least a couple of what we've got there. So let's get this right. So we have B and D. The expected return for both of those is 10%. But the risk for B, in terms of our standard deviation, is a lot lower. So it doesn't make any sense, surely, to go for D. Yeah, there's more risk and the expected return is the same. In the same fashion, the risk for C and E is the same. The standard deviation is 25, I think. So C would clearly be better. The expected return is 25% compared to whatever that was, around there somewhere. So we can probably eliminate 2 of those. B's gone. C's gone. Sorry, E's gone. Thank you. You're on the ball. So we can eliminate 2 of those. But how would we make a decision with respect to the other 3? Same question, which one would you choose? Oh, that's an interesting one as well. High returns, okay.
Lowest risk to capital.
All right. Highest return, lowest risk, yeah, okay. Someone made the point there. Partly it depends upon your attitude to risk. All right, so we can't say for sure. You know, different choices there could be equally rational for you because of your extent of risk aversion or indeed if you are a risk lover, which it suggests that some people might be. So, not possible to say with certainty. But what we can do is try and identify which of these provides the best risk-return trade-off. So, the level of return given the amount of risk involved. And we can do that, I think, by adding a little line to our diagram here. Flat line implies lots of risk for very little return. As the line gets steeper, so moving in that direction, it implies not much extra risk for a lot more return. So what we can do is take our stocks and see which one just touches the steepest line possible. And as you can see, in terms of what we've got here, I think that's C. Tell me if I'm wrong. I'm just double checking. Yeah? So, in terms of these particular stocks that we're looking at, then the best risk-return trade-off would be with the stock or the share labelled C. And just to give you an indication of what that line is representing, it gives us the amount of return which is generated for a 1 unit increase in risk. And the slope of that line, as you can see, is 0.68. So a 0.68 unit increase in expected return is what we get for a 1 unit increase in risk. And if we're risk neutral, then that's what we choose. But as you guys have said already, some people are risk averse, maybe some people are risk lovers. So it may not be quite as simple as suggested there. Also, what I was suggesting to you with the little example, which came from Samuels et al., was you had to choose one. And I think one or two at the time said, well, why don't you mix them up? Why don't you have more than one? And that's another possibility here which dramatically changes the scenario. So now think in terms of constructing portfolios. Hence the notion, again, which one or two of you mentioned, of diversification.
How did you arrive at 0.68?
The 0.68? What did I do? Right. That was our risk-free, no risk, no zero standard deviation, and the return was 5. Then what I did was work out the slope of the line up to our different possible stocks. So, that was C. That was our line. The figure for C was 15 and 18, yes? No, I got the wrong one here. Yeah, okay. So C was 22 and 25, yeah? So 22 and 25. What you can then do is work out the slope of that line. Something we used to have to do at school, yeah? Even though some of you might have forgotten a little bit. But that was the kind of principle that I used to then say, well, the line's 0.68, or roughly 0.68. So, that was when we were looking at individual stocks, individual shares.